Welcome to solverfy.
Okay, so this question, we want to prove that for any real numbers, we can write x in terms of n plus by epsilon, where n is a natural number and 0 is less than or equal to epsilon is less than 1, or less than 1. And we want to prove that this is unique. So first thing, we split it into cases. So when x is an integer, or sorry, not a natural number, integer. When x is an integer, then this is very trivial because we'll just say epsilon is equal to 0. Then x will just be, well, the natural number will just be x. So x is equal to n is just very trivial. For the other case, when x is not an integer, to do this, what we'll do is just let's visualize it once again. So if x is not an integer, then we can always bound it by some sort of interval m plus 1. And then x will have to lie somewhere between here. So to write this out, there exists m, which is an integer, such that m is less than x is less than m plus by 1. So x is here. Then epsilon will just be the distance between this and this. So then epsilon, we define epsilon as being x minus by m. So then, m plus by epsilon is equal to x minus by m. I'll put m plus by epsilon, which is x minus by n. The two m's cancels, so this gives you x. So therefore, x is equal to m plus by epsilon. So this is a constructive proof. So we just constructed this whole thing. So we're done. So to prove that it's unique, though, it's unique because the distance between m and x must, to have epsilon to be less than 1, this m is unique. Because if we suppose went down m minus by 1, well then the epsilon will have to be 1 plus by, let's make this delta. So the epsilon here now will have to be 1 plus delta. Same thing as if we went from m plus by 2. The epsilon here now will have to be, well, if this is now epsilon, let's say gamma, well, this has to be 1 plus gamma now, which is clearly going to be greater than 1. So therefore, it's unique because this epsilon restriction keeps us within this single domain.